Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 25 of the November Daily LeetCode Challenge. We have only 5 days to go to get this badge of the November Daily LeetCode Challenge, and we again have a hard question in front of us. Okay, so as you might be knowing, if you have been following my video, from the last 5 or 6 days, we have been getting questions around the topic of metrics. Okay, and today we're getting the hard question. And remember, this is the second hard question in November Daily LeetCode Challenge we have seen till now. Okay, this is the second hard question. Previously, around 1 week back, we had another hard question. This is only the second hard question in the November Daily LeetCode Challenge. Okay, so let us see what it is. Let me say this is not difficult. Only thing is, like, yeah, the way they have mentioned it, it looks difficult, but if you get to see the constraints, you will get to know that it's very easy, and ultimately you will get to know that we're just solving it almost with approach which is similar to brute force. Okay, but obviously there is algorithm involved, and through that we are solving it in a brute force approach. Okay, we'll get to know that, but let's quickly begin the question. So I am assuming that you might have already gone through the question before clicking on this video, but let's go through it once again. Okay, so let me zoom in. So basically, if you see, we are given a grid like this. Okay, the grid size is always fixed. Okay, it will be always 2 cross 3. That is, it will always have only 6 elements, and the values are also fixed. The values will always be 1, 2, 3, 4, 5, and a empty box. Okay, the empty box is shown as 0. So the idea here is always the size of the box is fixed, which is 6, and always the elements of the box are also fixed. It will be 8 from 0 to 5. Okay, so let's see the question now. Yeah, a 2 into 3 board. There are 5 tiles labeled 1 to 5 and an empty square represented by 0. Okay. A move consists of choosing 0 and a 4 directional addition number and swapping it. Okay. So remember, the move will always happen from 0. If you see here the white box which is shown as 0, so what will happen is from this 0 you can swap it with any of its adjacent box. So when this adjacent, what it means that any of the horizontal or the vertical adjacent box. Okay, remember, not diagonally. Okay, so only the vertical and the horizontal and 0. For example, in this case, this 0 can be swapped with 5, this 0 can be swapped with 4, this 0 can be swapped with 2. Okay, these are the three options here. Okay, so similarly, that's what they're trying to say. Okay, a move consists of choosing 0 and a 4 directional adjacent number and swapping it. The state of the board is solved if and only if the board is 1 to 3, then 4, 5, 0. So see, this is the state in which the board will be called solved. Okay, so if you see here, let me zoom in. So what it says is 1 to 3 will be there in the first row, and 4, 5, and 0 will be there in the last row. So if you see the example one, first row is matching. Okay, the target, only the second row is not matching. Okay, so what will happen, after 4, 5 should come, and then the 0 should come. Okay, that is what it is. Okay, so the state of the board, if it, so the solved state, okay, is something like this: 1 to 3 and then 4, 5, 0. Given the puzzle board, return the least number of moves required so that the state of the board is solved. Okay, if it is not possible for the state of the board to be solved, return -1. So see, one thing is very clear. I hope you are clear with the question. What is the question? See, if you have to understand this question, you have to understand what is a move. So what is a move? Move consists of choosing the number 0 wherever it is. See, 0 can be in any of the 6 places, right? Do you agree with me? See, the dimension of the board is fixed. There can be only 6 elements, and the values of those elements are also fixed. It will be always 0 to 5. Okay, so let us say value 0 is at any of these 6 places. So what it can happen is, it can swap with any of the 4 directional addition numbers. Okay, that is, any of the addition numbers to it, it can swap among them. Okay, and after swapping, whatever, we have to keep swapping the way you want, but after that you have to get to this stage. Okay, you have to get to this stage. If you get to the stage, that means you have reached a solved state. But see, the idea here is, you may have to do certain number of swaps to reach this particular stage, that we will see now. Okay, those number of swaps are going to be our answer. Okay, they are saying return the least number of moves required so that the state of the board is solved. Okay, as simple as that. So we will see the examples now, but at least this part should be clear. Okay, because it's a hard question. I am expecting you to understand everything very, very keenly. Only then you will realize how easy this question is. Okay, so first thing is clear. The other edge condition here is, if we cannot reach the solved state of the board, we'll have to return -1. Okay, so let's see the example one now. As I mentioned in the starting itself, remember, see, this part you have to remember. Only then you will be able to understand the examples. Okay, 1 to 3 in the first row, and in the second row 4, 5, and 0. So if you see this example now, the first row is already the way we want. Only the second row has some issues. Okay, it should be 4, 5, and then 0, but here it is 4, 0, and 5. Okay, we want 4, 5, and then 0. So what we can do, we can swap this particular 0, okay, with 5. I can swap these two. Okay, so I will get the required configuration in the second row also, and first row is obviously in the required way only. So basically only one swap is required, that is, only one move is required. Okay, swap 0 to 5 in one move. Okay, so this is the most efficient one. And remember, in the answer they're clearly saying the least number of moves. Remember that. Okay, you cannot say simply some number and you can give it. Okay, that's not the case. Okay, because remember one thing, it can be circular also. That is, after see, idea here is, let us say by one move I can get it. There will always be a number which is greater than one. In that way also I can get it. That is, let us say I can this particular 0 can move in the whole matrix. Okay, so we can get the same configuration back again after certain number of moves. Okay, so that is the basic idea. That's why they're saying the least number of moves. Okay, remember this part. So let us see the other example now. See, other example is very important. Here they're written in -1. I cannot draw it and show it to you because there is no answer for this question. Okay, example 2 doesn't have answer. That's why they're written in 0. But yeah, in my code, I will explain this part with the tracing. Okay, so we will know that while explaining the code. Now come to this particular part. Example number 3. So if you see here, nothing is, row 1 is also not the way we want, and row 2 is also not the way we want. Okay, so what we can do, see, try to understand it in this way. What we will do is, we will see 1 2 3 is here and 4 5 0 is here. Okay, so what we can do is, let us say this particular is thing is, we will try to replace it with 5 first. Okay, and then it will replace with 4, and then with what, then with 2, and then with 3. Okay, so it will be like anti-clockwise direction. If you replace them, you will get the answer. Okay, that's what they're trying to show you. Okay, so you can go through this, but the idea here is very simple. First you have to replace 0 with 5. Okay, this particular 0 with, we have to replace with 5, and then 0 will come in the place of 5. This 0 we have to replace with 4, then 0 with 1, 0 with 2, 0 with 3, and then you will get the required configuration. Okay, so it will take basically 1 2 3 4 and 5. So total 5 moves will be needed, and the answer is 5. They've drawn and show it to you, but yeah, it may look complicated, but once you understand the logic, try to imagine it yourself, it will become easy. Okay, see, reading it in this particular way looks bit confusing and difficult, but yeah, don't be confused, it's very very simple. Okay, now just imagine it in this example 3. You have to just move the 0 in a anti-clockwise, sorry, it is not anti-clockwise, it is clockwise. Basically, in a clockwise direction, you will get the answer, right? Fine. Now the most important part, why this question becomes easy, is because of this. See, the configuration of the board is fixed. Okay, that is, if you see here, it is always 2 cross 3. Okay, it is always 2 cross 3. It can never increase, so it is fixed. Similarly, the values of the votes are also fixed. Okay, and it's guaranteed that the, see, it's always going to be between 0 and 5 only, with nothing repeating. Okay, that's the basic idea. So see, one thing is very clear. See, because the board is very very small, we can basically simulate all possible configurations. That is how, what all possibilities are there for my 0 to move, so I can simulate them. Let us say you are doing it in a brute force way, or any way you want, you can do that, and you can get the answer. But just one thing that you have to remember is that, remember, things here are cyclic. That means, see, for example, in example 1, I got the answer as 1, but the thing is, you can still continue moving 0, and can still reach the answer state, but the number of moves will be much higher. Okay, so the idea here is, you'll have to stop at some point, otherwise it will be a endless cycle. That is the only thing here. Okay, you have to take care of that. And so before doing that, let us show you the code that I'm going to use. So see, the most important part is understanding the possible moves. See, one thing is very clear. I will see, because it's a 2D array. Okay, it's a 2D array, and configuration is always a 2 cross 3. So what I will do is, I will try to make it as a single array, that is 1D array. Okay, so for making it as a 1D array, it will look something like this. Okay, so please pay attention here. This part, if you understand, rest of the parts are very very easy here. Okay, so see, this is how my array will look now. Okay, so initially it is like this. Okay, it, if you see, this is how the array is given to us. I'm writing their positions here. Okay, this is a 0 cross 0 element, this is a 0 cross 1 element, 0 comma 2, 1 comma 0, 1 comma 1, and 1 comma 2. Okay, this is how the array is given to us. Okay, remember, this configuration fixed throughout this question. Okay, it will always be 2 cross 3 matrix only. Okay, first thing is clear. Now I want to make it as a 1D array. So what will I do? See, this part will remain as it is. After that, I will start appending these elements. Okay, so this is how my array will look like. Okay, 0 0 0 1 0 2, and then 1 0 1 1 and 1 2. Okay, so these are the indices for it. Okay, so if I basically see, this is how my array is given to me. Okay, fine, and this is how it will, I have to imagine it is, as it is. Okay, because these are the 0 1 2 index elements, and these are going to be 3 4 and 5 index elements. Okay, that's how I have to imagine it. Okay, so this is the actual configuration given to us, and this is the configuration that I am going to use. See, here I am writing 0 1 and 2, these are basically indexes. I am going to store it in a single array only, just for you to imagine how the array will look like. This is how I am showing it. Okay, so basically, can you quickly tell me now, the number which is at this particular index, to which all elements it should swap with? Okay, it can swap with this element, okay, which is adjacent to it, and it can swap with this element which is adjacent to it. Okay, do you agree with me? The number, let us say, if this number I want to swap, let us say 0 is in 0th index. Okay, remember, these are indices, so 0 can be any of these indices. Okay, so we'll have to go through each of the cases. Okay, let me make it a bit bigger. Yeah, so let us say 0 at in this particular index. So which element it can swap with? It can swap with any number that is present here in one index 1, and any number that is present in index 3. So the idea is, whenever the 0 is present in the 0th index, it can be swapped with 1 and 3. Okay, do you agree with me? So that is what I'm trying to capture here. Okay, whenever the number is 0 is present in 0th index, it can be swapped with 1 and 3. Okay, let us see one more case now. let us say 0 is here in the 1th index. When 0 is in the 1th index, can you quickly tell me to which indices it can be swapped with? Okay, it can be swapped with this number because it's horizontal adjacent, this number is also horizontal adjacent, and this number is also vertical adjacent. Okay, so if 0 is in the 1th index, it can be swapped with this number, this particular number, and this particular number. So 0, 2, and 4. So for the index 1, if you see, that's what I'm writing, 0, 2, and 4, and so on. Okay, so like that I've done. So I'm doing this. First thing is, I'm creating the 2D array. I'm making it as a 1D array. Okay, this is how it will look like. I'm assigning some particular indices for the each position of the array. Okay, for 0, 0, the index will be 0. For 0, 2, the index will be 2, and so on. Okay, for 1, the index will be 4, and so on. And then I'm trying to map them. Okay, so this is how the mapping will look like. This just for your understanding. I'm doing it. Okay, and then I will have to configure when this particular position can be swapped with which another position, because see, 0 can be any of these, right? For example, 0 can be here, 0 can be here, anywhere. So whenever the 0 is at position 5, okay, to which position it can be swapped with? It can be swapped with 2 and 4. Okay, for the position 5, it can be swapped with 2 and 4. Okay, that's what I'm writing here. So this particular array, possible moves will tell me that. So if my 0 is in this particular positions, either 2, 3, 4, wherever it is, so these are the possible values through which it can be swapped with. Okay, that is one thing. Okay, next thing is, okay, I will come to this later, but just understand it one way. What I'm doing is, I am going to convert the given state to a 1D array, and this 1D array I will be converting to a string. Okay, for example, this is how it will be looking like. Okay? This is going to be my target state. For example, if you see here what they are giving, yeah, 1, 2, 3, and 4, 5, 0. So what I will do, 1, 2, 3, I will write as it is, and the second row I will just append it after that. Okay, 4, 5, 0. So this is going to be my target state. Okay, so yeah, that is all it is. And the idea here is, see, whenever a 0 is present in some position, I will have to swap. Okay, the idea here is, for example, 0 is in the 3rd index, means it can be swapped with 0 and 4 index. To swap that value, I'm using this particular function. What it will do, it will take the current string. Okay, that is, see, current string means the current state. Okay, it will take that, it will take the current position of 0, it will take the next position of 0. So current position of 0 will be, for example, in this case it will be 3, and the next position of 0 will be, first it will be 0 and then it will be 4. For each of this 0 and 4, I will call this function separately. Okay, this function will be called for each of these values. Okay, 0 and then for 4. Okay, so the 3 will be the position of 0 and either 0 or 4. Okay, each one of them I will call separately for this particular function. So next position in this case will be 0 and 4. Okay, or 3. So that's how it will be. So what it will do, it will take the current state, which is a string, it will make a list out of it, because remember, in Python we cannot make changes to a given string. Remember that we cannot go to index and change its value, something like that. We have to make it as a list. I call it a state list. Then I will go to state list. In the position of 0, I will change the position of 0, that is what is there in the position of 0, I will assign this particular value. Okay, the value at the next position of 0, then the next position of 0 will be 0. Okay, and then I will return it again as a string. Okay, this is what this function is doing. Next, what I'm doing, so remember, the solution that I am going to do is a BFS approach. Okay, because DFS will be bit costly here. I am going to do the BFS approach. I will get make you understand that what it is, but just see the things here. Visitor set is a set. It will record, so that's why it's in the starting of the question itself, because the states are repetitive here. Okay, once you reach a state, you will reach there again after some moves. Okay, so the idea here is, once we reach there, we should stop. Okay, as simple as that. Because in case of BFS, basically, whenever we reach a state, we are reaching there in the least possible time, because the next time when we reach it, it will be bigger, number of moves will be bigger. So the idea here is, whenever we reach a state, we should not reach it again. That's why I'm calling it a visitor state. Okay, and this is going to be my target state because it's there in the question itself. Okay, this particular state is the target state. Okay, 1, 2, 3, 4, 5, 0. It's a 2D array, 2D state, but I'm making as a 1D state, and then I'm making as a string, and then the current state. Okay, so current state, what I'm doing is, the way the row is given to me, okay, in the board, I'm taking each element and I'm making it as a single state. Okay, so that's how it is. I can print and show it to you how it works. Okay, first let me print and show it to you. Fine. So basically, if you see, yeah, this is the example one. Okay, so 1, 2, 3, 0, 4. Sorry, just a second. Yeah, 1, 2, 3. So sorry, it's example that I'm showing to you. Yeah, 1, 2, 3, 5, 4, 0. So see, the string will look like this. Okay, something like this. Okay, that's what I'm trying to show you. And I will have to comment out this part, and then the real output will come. Okay, fine. So what I'm doing, I'm going through each row in the board, and for each element in the board, I'm appending it to my current state. So my current state is ready. I'm converting the string, and then I'm appending it to the current state. So I'm printing it just as I showed you. Okay, so whatever it is, it will be in a single row, that is 1D, and then it will convert to a state, a string. So what I'm doing, first of all, it will be converted to a 1D list and then to a string. So there are two transitions happening. Okay, fine. Then what I will do, I will find the current position of 0. Okay, to that I'm using the find function. It will take around O of 6 time, because there are 6 elements. So O of 6 time it will take, which is a constant time. It will find the position of 0, and that I will call the position of 0. Fine. Then I'm declaring a queue. I'm calling it as a DQ. Remember, DQ is a data structure in Python. So DQ is basically double-ended queue. Why any double-ended queue? Because if you see later in my solution, basically I'm using the pop left function. That is, from the 0th index, pop the element which is present in the 0th index. So do pop left in O of 1 time, you basically need to use the DQ function in Python. Okay, fine. So this is going to be my one element in my queue. Remember, this is just a one element in my queue, not three elements. Because see, I'm using a tuple basically. This whole thing is called a tuple. Remember, it's a single element, not three elements. It's a single element. So single element will have three parts. What is this? First of all, the current state. Current state means the string that I showed it to you. Okay, this whole thing in a string is called the current state. Okay, then the position of 0. What is the position of 0? Position of 0 is something that we are finding using this. Okay, based on the question, it will be changing, but this variables will store the current, that index of 0. You can call it as the index of 0. Fine. And then the number of moves. So the third part is the number of moves, because initially, because I'm just appending it, like I'm just starting my solution. So initially it will be 0. Okay, if the initial state itself is the target state, then I will return this as the answer. Okay, so this is my queue. Then I'm going to start the BFS solution. What is BFS? Idea here is, see, what, for example, in the example one, let us go to example one. Yeah, in this case, basically this particular 0 can go to either 4, or it can go to 5, or it can go to 2. Okay, so this all will form part of my round one. Okay, so I will append all these three states in my okay, I will do a tracing of it, and I will show you. But this is the basic idea. Okay, see, all distance that are at move one will be part of my queue in the first step. Okay, after that, again, I will go through all the steps, all the positions that are at move 2, then all the stuff that are move 3, and so on. So that is how it will be working basically. I will show it to the output, then it will be very clear. Okay, so this is, I'm starting till my queue is not empty, this will be processed. Okay, so what are these things? I will first do a pop left. Okay, so whenever it's popped, I will capture these particular things using these three variables. Okay, current state, position of 0, and move. Okay, fine. If my current state is equal to target state, then whatever is the move, I will return that as the answer. Okay, if current state is already visited, okay, that is, once again, like previously also I've reached this state, so I will not proceed further, I will do a continue means go to the next part of the while loop. Okay, that is, do not go through this part of the code. Okay, go to the next iteration of the while loop. That is the basic meaning of continue. Okay, fine. See, through this I'm ensuring that there is no infinite loop going on, right? Fine. Since, like, once we come out of this, that is, if this code is not executed, that means their state is not reached. So what we'll do, we'll add it to the visitor state. Okay, as simple as that. Fine. Next, what I'm doing, let me use, yeah, next what I'm doing, next I'm going to use this particular thing. Okay, the possible moves. For example, if you see in this, the current position of 0 is this, so we'll try to find what are the next position of 0 based on this particular, this thing. Okay, see, this is called a mapping in Python. Okay, key value pairs. So I am trying to check if, yeah, for next position of 0 in possible moves of current position of 0. Okay, so that's what I'm doing. So this is the current position of 0, right? So this is basically one of the keys here in this. Okay, this is basically one of the keys in this. So based on that, we will decide what are going to be the next positions. Okay, that's what I'm trying to do it here. Okay, so for next position of 0 in possible moves in current position of 0. Okay, so these are going to be the next possible next position of 0. What I'm going to do, I'm going to call this swap function. Okay, swap position function. I will pass the current state, I will pass the existing, that current position of 0, and the next position of 0. It will do the swap basically. Okay, it will do the swap. That is, 0 will be initiated like this in this index, then it will be brought to this index, and it will be returned. Okay, so this is the target state, that is the next state. Okay, is the next state where 0 will be present in next position of 0. Okay, that's the next state. So what I'm going to check, if this is not visited, only then I will be putting it in my queue. Okay, I will be putting it in my queue. Remember, append means basically append in the right. Okay, remember that. But pop is see, pop is happening from left, but we are appending in the right. Okay, remember that part, because see, all the idea here is whichever has the least move, least number of move, that will be executed first. That is, all the moves, all the states that are at distance one. Okay, that are at distance of move one will be executed first, and then what are distance of two, that will execute next. So like that will be going on. Remember that part. So that's why I'm popping from left and I'm appending from right. So that is how it is. Okay, so this particular element I'm going to add it to my array. That is q. What is that? The next state, the next position of 0, that is the position of 0 in which is in the state. Okay, and then move plus 1. Okay, to reach this move, to reach this state, I need basically this much number of moves. So what is the current move? I'm just doing a plus 1 into that. Okay, because I did a swap, so basically that will take 1, so I'm doing move plus 1. Okay, as simple as that. And fine. and then we are just printing the q, and then we're ending it. Okay, this value will continue till there are till all the possible states are not reached, and then this, because of this particular thing, okay, because of these things, it will be coming out of the loop. Okay, fine, and then we will return -1 if this part of the code is not reached. Okay, if this part of the code is never reached, then we'll have to ultimately return -1, because in the question also they have mentioned the same. Okay, if you see here, that's what the question is, basically return -1. So like, let me quickly run this code now and show you the output. Yeah, so we will do the tracing for example one, because that is, yeah, easy. So see here, first what will happen is, see, 0 is here. Okay, so there are three cases where 0 can move. Okay, 0 first of all can move to 2. Okay, so see, this is the case where 0 moved to 2. Okay, 0 replaced 2, so 2 will come down and 0 will go up, so it will be 103 and 4 to 5. Okay, that's how it is. So what is the position at which, so this is the number of move. Okay, and this is the position at which 0 is present. Okay, if you see 0 is present in index 1, that's why this particular thing is 1, and this is the number of moves. Okay, similarly all the three areas will be calculated. So if you see, all the common in all three is that the number of move is 1. Okay, number of move is 1, because these are all at a distance 1 from the current node. You can think it like that. Okay, it's a BFS algorithm, so you have to imagine basically in terms of graph. Okay, and fine, next thing is 0 can replace 4. Okay, remember, just for the, see, which all things are at a move 1, that's I'm first all I'm showing you. Okay, then 0 can replace 4. Okay, so it will 1 2 3 and 0 4 5. So it is like this. Next thing is 0 can replace 5, so it will 1 2 3 4 5 0. Okay, as simple as that. That's how it will be. Okay, since remember, this is solution basically. Okay, this is the solution. So idea here is, see what will happen next. See, since this is again, inserted first, this will be executed, then this will be executed, and then this will be executed. When this executed, will release the solution basically. Okay, if you see next, we are basically trying to execute this, that is from here where all I can reach, it will be like that. Okay, if you see here, these two things, okay, are coming from that. Okay, I will actually exploring this, that is from here which all positions I can go to, and from that I'm getting these two. How I'm getting to know that, see, here the number of moves is 2, here the number of moves is 2. Okay, fine, then what is happening, then this will be executed, that is this particular thing. Okay, which is this. Okay, first this will be executed next. Okay, so because it's at the left, so always popular development, so this will execute it first. So because of this, we will getting some more things. Okay, so we are getting yeah, this and this thing I'm getting. Okay, finally this will be executed, which is the solution, and I will getting the solution. Okay, as simple as that. So yeah, fun, that was, yeah, the thing. And if you see here all the test cases, so yeah, example for the case 2, basically you can see it. So if you see how much output is coming, basically that's much iteration will be happening. Okay, this much things will be, you can see it how big it is. Remember, for this we are actually -1 is the answer, right? For that reason, for example, basically -1 is the answer. That's why I was not doing the tracing for this, because see how infinite tracing is coming here. Okay, how infinite tracing coming, because we are going through all the possibilities, and ultimately, since we are not getting the answer, we have to return -1. Okay, so that is the part. Fine, for example 3, yeah, you can go through the output basically. Okay, but yeah, at most, see, we are getting 6 moves. Okay, but after that we are getting the answer. So that is the basic idea. See, at most 6 moves, but since one of them is the answer, so 5 is the answer. Okay, but before reaching 5, we are we are basically what we are doing is, before reaching 5, some more moves that are there, that will be explored. For that reason 6 is coming, but yeah, then we will be getting the answer. In the example 1 also, if you see, the same thing happened. Okay, we reached till move 2, but the answer is 1. Okay, why? Because see, this is the answer, but before we reach here, that, see, this is the answer, right? But before we reach here, these two will be explored. For that reason, you'll see some of the entries which have moved to in the DQ, but once you reach the answer, that will be written. Okay, so if you talk about the space and time complexity, see, it's very simple. See, totally it's depend on the combination and permutation. Okay, so if you see, there are 6 places. Okay, 2 into 3. Okay, so the dimension is 2 into 3, which is 6. Okay, so basically I can arrange them in 6 factorial ways, which is 2 into 3 factorial ways. Okay, fine. Now once I combine them, it will become array of 6. Okay, length 6. Okay, so basically for each such position, I have to do all this part, right? I have to, like, I'm calling this function swap function. What is happening, basically it is swapping the value. To do that, it's first of all converting to a list. So all these operations will take O of n time, what is then in this case 6. So for that reason, for each combination like this, okay, each combination or like this, we have to do this much thing. Okay, so idea here is, it is, yeah, 2 into 3 factorial into 2 into 3. Why? What is 2 into 3? It's the length. Okay, that is 6 factorial into 6. Okay, because see, this is O of an operation, right? See, for this reason, I'm doing it O of 2 into 3. Remember, 2 into 3, say 2 into 3 is 6, right? 6 you can call it as n in this case, because the single 1D array that we're creating will be of length 6. Okay, So it's something like this. Okay, 2 into 3 factorial, because six elements can be arranged in 2 into 3 factorial with 6 factorial base, and for each such combination, each such array, we have to do this kind of processings. For that reason, it will take 6. Open. Okay, so we are multiplying them, getting the answer. Remember, still it is constant. Remember that still it will be a constant value only. So the idea here is, even for the irrespective of the value of n, basically this means calculations will be happening until and unless we are getting the answer through this. Okay, if we get the answer through this, it is well and good. Otherwise, this much calculations will be happening. As simple as that. Okay, in the worst case. Other than that, talking about space complexity, see, there are only two things that is consuming space. Okay, what is the first thing? The wasted state, and other thing is the queue. Okay, the queue in itself. Okay, so the queue in itself. So in the worst case, what will happen is, yeah, it will be consuming space for all of the combinations here. Okay, all the possibilities of the moves. Okay, all the states are possible. So that also will be 2 into 3 factorial, which is equal to the 6 factorial. Remember, all of them are constant, so it doesn't depend on n. But the thing is, once we reach the answer, we are returning it. So remember, these are just the worst case scenarios. Okay, once we reach the answer, basically we are returning it. Remember that. So these are just the worst case scenarios. So one improvement that you can do is that, before while you are appending the thing, basically, so what you can do is, here itself you can check whether it's the target state and return the answer. So that what will happen is, as you saw in, like in my case, right? So yeah, in the example one, you see this is the answer, right? But still, what is happening? We are simply appending it, and first this will be processed, then this will be processed. At last, we are coming to this. To avoid this, you can, like, what you can do is, here itself, basically, while you are appending to the queue, what you can check is, if it is the answer, you can return here itself. Okay, that will be one optimization. Okay, that could be one of the optimizations. But remember one thing: if the first, that is the target, the current state itself is the answer. Okay, the first state that is given in the question is the answer. Then this will not be executed, because that part is happening here. Okay, so yeah, if you see here, I'm appending this to the queue here. The first state will append to the queue here. So here also we'll have to add another check condition, that if current state equal to target, we have to return the answer, and then you can remove this part. Okay, then you can remove this part, and you can add it here at this particular step. Then it will be a good one. Okay. So Afan, that was all for this video. If you like my efforts, please do subscribe to my channel. See, my effort is very clear to make things easy for you in the programming world. This was a hard question. Okay, many people would have seen this and they would have refused to do it because it's marked as hard. But like I showed you, it's not hard, it's easy. Basically, only thing is you have to know certain things. So yeah, if you like, see, you will get these hints in your interview, in your face-to-face interview. They will give you hints. Only thing you have to do is, you have to know how to solve it after you get the hints. Okay, so this is the only thing that I want to show in this question. Okay, so the if you learn anything from my video, okay, if you get anything from my video, if you get any help from my video, please subscribe to my channel. It really gives a lot of motivation to continue further. Okay, so yeah, and that was all for this. It was day 25. We have only 5 days remaining. See you tomorrow. Thanks a lot.